Welcome back to Math with Ms. Reimer. Today we are looking at Section 5D, which is continuing with elimination when we have to find equal and opposite coefficients. The main premise for today is if there are no equal and opposite coefficients in the original problems, you are going to multiply one or both equations by some number to force equal and opposites. What this looks like is, take a look at example 1. Right now we see that we have an x and 1x and 2 and 3 and negative 7. Neither of those are equal and opposites. However, if I multiply the entire top equation by negative 2, that would force this to become negative 2x, which is equal and opposite to the 2 here. When I go to multiply, I'm going to take that negative 2 and distribute it to each piece in the equation, and I will end up with negative 2x minus 6y equals a negative 12, and then this equation will just come over. Now I can do the same thing I was doing before. I can add both equations together. The x's will cancel, and negative 6y and negative 7y become negative 13y, and the negative 12 and the negative 1 become negative 13. I'll end up with y equals 1, and that's the first part of my answer. Just like before, I'm going to take my 1 and I'm going to plug it in to any of my equations because these two are equivalent and this one will work as well. I'm just going to go back to my original equation where I had x plus 3 times y, or 1, equals 6. Subtract 3 from both sides, and we end up with x equals 3. So if I multiply this entire second equation by negative 3, that would leave me with equal and opposite coefficients. So when I multiply through, I'll have negative 6x minus 3y equals negative 15. My top equation just comes over. Be careful that you make sure you distribute that negative 3 to each piece of the equation. Now I'm going to add through. When I do that, 9x minus 6x is 3x. My y's cancel, and 12 minus 15 is negative 3, or I get x equals negative 1. That's half my answer. I need to take that negative 1 and plug it back into one of my original equations. So I'll just work with the first one. 9 times negative 1 plus 3y equals 12 is negative 9. Add 9 to both sides. We get 3y equals 21, or y equals 7. Put those answers together in your ordered pair, and you get negative 1, 7. In example 3, when I look for equal and opposite coefficients, I've got 3 and 5, and then a negative 1 and 4. The negative 1 and 4 will be easiest to match, so I'll multiply this top equation by 4. That will leave me with 12x minus 4y equals 56. Then my bottom equation stays the same. There's my equal and opposites with my 4 and negative 4. Now I can add through both equations. 12x and 5x gives me 17x. My 4's cancel, and 56 and 12 gives me 68. When I divide both sides by 17, I end up with x equaling 4, which is half my answer. Take that 4, plug it back into one of your original equations in order to find what we're looking for, which is y. This will give us 12. Subtract 12 from both sides, negative y equals negative 2, or y equals positive 2. Our final ordered pair will be 4, 2. Look for the least common multiple, or the smallest number that both either 3 and 5 or 3 and 4 multiply into. I'm going to try and get rid of my x's, so I'm going to focus on those. I'm thinking of what is the smallest number that is divisible by both 3 and 5. Well, 3 and 5, you're looking for 15. So I want to get both of these x's to 15, one to positive 15 and one to negative 15. So to get started, if I take my first equation and I multiply it by 5, I will get positive 15x plus 15y equals 45. Now to get equal and opposites, I need to multiply my second equation by a negative 3, because negative 3 times 5 will give me a negative 15, and there's my equal and opposite, which is what I'm looking for. Multiply through everything else. Now I have equal and opposites, so now I can follow the steps I'm used to. I can add both equations together. My x's will cancel. 15 and negative 12 will give me 3y equals 15, or y equals 5. Once I find one piece, plug it back in. You can plug it into either of your original equations or the new ones because these are equivalent to their original sets. So plug 5 back in. I'm just going to use my first equation. So 3x plus 3 times 5 equals 9. We get 15. Subtract 15 from both sides. I get negative 6, or x equals negative 2. That leaves this ordered pair as negative. Common multiple of 2 and 5. So I'm looking for the smallest number that's divisible by both 2 and 5. In this case, I'm looking for 10. So to get 2x to be 10x, I need to multiply my whole first equation by 5, which will leave me with 10x minus 20y equals 90. My second equation, I need my x term to be negative 10, so it cancels with my positive 10, so I can multiply the whole equation by positive 2. 2 times negative 5 is negative 10x. There's my equal and opposites. Then I've got a negative 12y equals 6. Now I can go ahead and add both of these equations together. My x's will cancel. I end up with negative 32y equals 96. And I get y equals negative 3. Once I know that y equals negative 3, I can plug that into either of my 4 equations. I'm just going to go back to my first one. So 2x minus 4 times negative 3 equals 18. That comes out to be 12. Subtract 12 from both sides, you get 2x equals 6, or x equals 3. Once you have both of those pieces, you can write your ordered pair, and that comes out to be 3. And in number 6, we need equal and opposites. So we can choose either the x's or the y's. Let's mix it up and look at the y's this time. I'm looking for the least common multiple of 4 and 6, or the smallest number that's divisible by both 4 and 6. In this case, we're looking at 12. So if I need 4 to get up to 12, I'm going to multiply by 3. So I will end up with 6x plus 12y equals 18. My second equation, I want this to be a negative 12 so that it cancels with my other one. So I will multiply by negative 2 to give me negative 6x minus 12y equals negative 24. You should be noticing right off the bat here that we've got 2 sets of equal and opposites. So both of these will cancel, leaving us with a 0 as a placeholder and then negative 6. If 0 does not equal negative 6, then these are actually parallel lines, and this is no solution as your conclusion. And final example in number 7, we need equal and opposites. Our options are 5 and 7 or 9 and 10. I'm going to go with the 5 and 7, so the least common multiple between these two numbers is 35. If you ever can't come up with one, you can always multiply them together, and it's not necessarily the least common multiple, but it is a common multiple, so it'll work. In my first equation, I'm going to multiply by 7, so I end up with 35x plus 63y equals negative 70. The second equation, I want this to come out to a negative 35 so that I have equal and opposites, so I'll multiply everything by negative 5. So I'll get negative 35x plus minus, or negative 50y equals 5. Add both of your equations through, your x's cancel. You end up with positive 13y, and then a negative 65. And when you divide both of those out, you get y equals negative 5. Now plug back in to one of your original equations. I'm just going to pick the first one. So we have 5x plus 9 times negative 5, because that's the y. Get negative 45 here. Add 45 to both sides. 5x equals 35, or x equals 7. Put those together in your ordered pair, and you get 7, negative 5 as your solution. This is Miss Reimer and Stanley signing off.